In the last few videos, we created two functions. First one was digits join, which should combine a list of digits into a single integer, and digit split, which should combine a single integer, which should separate a single integer into a list of digits, right? Okay, so today we are going to be looking at a programming challenge from excessism, and basically the challenge is to convert numbers from a particular base to a different base. So for example, to convert 1 base 2 to base 10, or to convert 101 base 2 to base 10. So, and more complex ones like converting from base 3 to base 16. So how do we approach this? First, we need to know how to do base conversions. So I found a good YouTube video, so I screenshotted this. So I think it's going to be better for us to tackle this on a step-by-step basis. So why don't we tackle the easiest one, converting from every other base to base 10. So first off, let's create a function that follows this signature. So it takes this base. Let's just copy this. Okay, so takes in the input base, the output base, and the input digits. So we can comment this for now, and let's use pattern matching to implement from any base to base 10. Base input base and the output base if it's base 10, and the input digits. So we can do this. Also, let's also prevent the case where the bases are the same. We'll do that after we do this. So so if the input base is, for example, base 4, I want to convert to base 10, we have to do the number position right. 4 times base 4 raised to power 2, then this will be 1 and this will be 0, right? So how do we do that? So since we have the input digits as a list, it's quite simple. So we can just say we fold. So we can use a fold just like we use here. We can use a fold, and for that let's use fold right as well. So we can say fold right the value and the accumulator, and for now let's just return the accumulator, and our accumulator is going to be let's make it a tuple as well, and the tuple is going to have the position and the value basically, and here we can pass in input digits for now. So basically what this would do is our accumulator is going to be this. So now let's destructure our accumulator over here and say, position and total. So, and what do we return? We need to return the value, and we need to return the next position rather, and we need to say the new total is going to be total plus the value multiplied by the position, the input base raised to the power of the position, right? So, so this is going to give us the base 10, but we need to return a list, right? So what we can do is we can pass in we can pass this to the digits join, the digit split function, which is going to separate the digits, right? And for that, let's use pattern matching. What's it called? Let's use function composition, right? So okay, yeah. So since we are doing since food right is going to return a tuple, we need the value of the tuple, which is the second element in the tuple. So we need to also add second to the pipeline, then go into digit split. So now we have this error of we can't merge int with type A. That's because our type A here is constrained by the integral type class. So probably we need to change all of this our int to type A and add the constraints to them, right? And instead of, we can add the constraints to them. Okay, so now that we have added that, the next thing we need to do is as you can see from the error message, it says rebase is supposed to return an either, but we are returning a list to it, right? So we need to pass that to the applicative pure functions. So basically this is going to return a write. So what we can do now is we can test this function. Let's export error dot and replace. So now if I go to GSC and I upload base dash, I can say base from base 2 to base 10, 101. So 101 and base 10 should probably give us 5, if I'm correct. Yeah, so that gives us 5. So we need to test it on like something that gives us multiple digits as well. So what if we do 15? Yeah, and it gives us 1 5. So now we have solved our first problem. The next problem is going from one base to going from base 10 to any other base, and that has to be done by division. But before we do that, let's clean up this. I think we can put this on multiple lines because it looks kind of messy to me. Yep. Yeah, I think this is a bit cleaner. Maybe still ugly, who knows? But this definitely looks a bit cleaner to me. So yeah, so the next case, so rebase when we have 10 as the input base and the output base is whatever it is. Whatever it is. Okay, so what do we do? In this case, our input digits is a list, right? And we don't want it to be a list because we need to perform division on it. So we need to use the digits join function we created in the last videos, right? So say digits join, right? And now that we have digits join, we need to perform this long division on it and then return a list. So to do that, I think we might need to create another function inside of that scope. So let's type this to div 0 and let's pass this to pure. Right, so now we can define div 0 should take in and it should return list. Okay, so what do we do? So div 0 num is going to be a loop or a recursion, I guess, and it's going to divide by what we have in this output page, right? So this is like a current case, so we can access this variable in this function, which is good. So we can say output base num divided by output base, but we need to return a list, and so let's say we do this, and then we need to like call this function again. But before we do that, so we need to develop a base case. So the base case is when this becomes 0. So when the number is 0, just return an empty list, and if the number is not 0, we keep dividing. And we also don't want, what we need to put in the array is the remainder actually. Yeah. So it's going to be, we are going to append to the array the remainder of this. So, but we get an error. Instead of doing, yeah, let's just take in the output base. Out base. Yeah, so we also need to put in the out base here. Yep, so that solves our problem. There used to be a way to match the types, but I guess we'll ignore it for now. And now that we have this should give us something, but I think it's going to be in the reverse of that. So if we refresh this and do rebase, input base is 10 and output base is 7, base 7, and the digit is 78. I think we're going to get yeah. So I put this the wrong way. It should be this. Yeah, I think I need to put it this way because we need to do function composition here. So yeah, let me swap this out. This as well. Okay, so if we refresh and do that, so we get 141, which is not a good way for us to test because this reverse is always going to be the same. So probably let's look at some of the test cases here. You know what? Let's just look for a base converter so that we can test our function, right? So we want to convert from base 10 to base 7, and let's say 128. This is still 1035. So we can use this to test that the order is correct. One, 6, 5, 1. So it's reversed. Just like I predicted, and it's because of how we are appending this, right? So we either have two options to append forward or to concat, to append it backwards. But instead of that, I think there should be a reverse function in Haskell which can reverse an array. Yep, so we just add that to the pipeline as well, and we should have a good, after reloading, we should have a 41561, which is expected. Good. So now that we have these two cases, what if we have a case where the input base is not base 10 and the output base is also not base 10? Then we need to add the those scenarios. So that would be our last scenarios. Rebase input base, and the input digits, right? So what we would need to do in this case is we need to add a condition. If we're going from, let's look at the test cases. So if we're going from something like okay, so from base 3 to base 16, for example, we would need to first convert base 3 to base 10, then convert it from base 10 to base 16. So how do we do that? So we first need to do rebase, impute base 10, and yeah, we can also use function conversion. And when we convert it finished, then we then pass the output, which will probably be it's going to be an either. So we need to extract the right from it. We would pass this to an internal function we create. Yeah, let me just call it base or error. Base or error. So what's that going to do? It's probably just going to mask this rebase function the exact same way. What it's going to do is it's going to input base prime, output base prime, and the input digits prime. But the only difference is this is going to be an either. We're going to listen for the case where this is a just, this is a right. Then we are going to return a real rebase, and the input base, but the input base now won't be it's going to be 10. So we don't really care about this guy. And the output base is going to be the output base. It's going to be the output base, and yeah, can also present no, it's going to be a case. Yeah, it needs to be a case. We really can't use guard, so that's right. Case D. Case D right D. Yep. So it's going to be a case of case D write D, and we need to remove this equal sign. And otherwise, it's going to be a left of. I'm just going to return D because D is the error, right? And I think we should rename this instead of rebase or error. Probably underscore rebase. Oh, it's probably name it rebase prime. Then say rebase prime. We don't care about the input base. So I can say input base. Or why don't we just use the input base? Yeah, why don't we use the input base? To input base. So and here the input base will have to be 10 and the output base will be output base. So now this should do the work for every other scenarios. So if we reload and try to do from, for example, from base 3 to base 16. So we do this, input base is base 3, output base is 16, and we're supposed to get to 10, right? Which we got. So the final step is validation. So we don't want people putting in negative numbers because right now if we try to do that, we're going to get unexpected behaviors. Yeah, we get an error. Or if we try to put that here, get an error. So we need to add in the case of we need to add in validations. So and the validations, one of them is going to be, we need to check if the input base is less than 0. So we can add in guards. So we can add in guards. So instead of this, we use guards. Right, and we say input base less than 0. When input base is less than 0, we return invalid input base. Left base. Yeah, so this is because we are doing function composition, so we need to find a way to ignore the last argument. So that is like the last argument, the third argument, which is the input digits. So because function composition is going to try to pass it into yes, so what we need to do is we need to return a function, right, that just does const. I think const can do that. Yeah. So and if output base is less than 0, we'll say invalid output base. Then for the last error, I think we need to check the test case, but it's probably for when like some of the digits are like negative. But for now, let's test our. So this should give us the invalid input base error, but for some reason it doesn't work. Yeah. Yeah, invalid input base. And if we do the same for the base 16 bits, should give us invalid output base. So, but the only thing we are yet to test now is when there is a negative number in our list. This is going to cause unexpected behaviors. Yep. So because this should have been 210 and we are getting something else entirely. So if we look at this, there should be a case for that. So we need to validate if any of the numbers are in the input space. So we can create another internal function. So the numbers must be greater than 0 and they must be less than the input space. Okay. So let's create a function that's going to check where there is an invalid input space. So we can say where as invalid, and what it's going to take is an integral, the input space, and the digits, and it's going to return a boolean. Okay, so yep, so so what we can do for this is we can also use, there's a function in Haskell called all, and what it does is if every item in a list satisfies a specific, like if every item in a list is true, for example, it's going to return true. So let's check it out. All. So what we can do is we take in the input space and we use function composition. So we can say all, and we can use a map function. Or we can also use list comprehension. But let's stick with map. So we can say our map should return true only if the number is greater than 0 and n is less than input base prime. Yeah, so all takes in a function that it's going to pass to the foldable rights. So and we just want it such that everything is equals to true. So we don't even need to use map then. We can just go directly this way. So now we just change this and bam. So if we do that again to our guard and we say as invalid digit, so we need to, so all is, so as invalid digit is going to tell us when everything is valid. So we probably need to pipe this to a not, right? So if we check I not, just going to invert it, right? So if it has invalid digits, then we are going to return a left invalid digits. So but invalid digits needs a parameter. So and what is the parameter it needs? It needs to return the invalid digits. So let's write another function to find the invalid digit. So it's probably going to have this kind of signature, but instead of a bool, it's going to return A. So okay. So we need to let's come back to this. So let's implement this first. Fixing the input base, and we can use the filter function in Haskell. I think the function is called knob, or if we do input that list, I say so it's in data.list knob, so it's a filter function, or knob by, knob by. So it's basically a function that lets you filter based on the predicates. So we can do our beautiful function composition again. So let's do not by this function, right? This exact function. And since it's returning a new list, so we're going to take the first item in the list. So there's a function called that can take first, but this is for a tuple. I think it's the take function. Yep, so we can use the operator to take the first item in the list. Yep, so we can use it. So I think we just have to be very sure. Yeah, we are going to be very sure, obviously, because we are using this function only when there is an invalid base. So we can say only take the first item when this is not. So what's the error we get now? Oh, so the filter takes in two arguments, not one, which is odd. Oh, I think it's not bias for sorting. Yeah, I should probably use filter. Ha, my bad. So we don't even need to import this. Yep, so this is what we need to do, and over here we can, instead of using all these const, we might not even need const again. And just say left invalid digits, and here we pass. Yeah, we do just this. So, but we have a problem. So it looks like there's probably no other way for us to do this without having the last argument, right? So we need to have input digits, which ruins everything now. So all our function composition needs to be gone. Right, so and we just do dot what now mate. Yeah, we do that again. And yeah, lastly here as well. So just return a left, and here we can just use the input digits, and oh yeah, we also need to change this. So we'll say left invalid digits and input digits. So yeah, and our problem is solved. So now if we try this, it should say invalid digits. But the problem is we are getting the wrong one. That's because the function we're using right here is wrong. So it should be any function that is less than 0 or it's greater than or equal to the input base. Yep, so I think we are all good, and now we can like test this function in excessism, right? So let me just add this and copy it. So if I go back to excessism and paste this and okay, yep, so I'm observing internet issues. So okay, so let's run the tests and see if all the tests pass or if we have messed something up. Let me run the test on my machine instead, because it looks like okay. success, even as it's so start test, I think. So 13 tests, one failure. So this is on line 18 of this file. It's not line 18. Input basis 1. Okay. So the minimum base has to be 2. Interesting. So the minimum base is 2, right? Okay. So this is going to be less than 2. Less than 2. So probably just copy this over to this file and test again. It might be that we also need to like add this guard to every single function we have, because my guess is in the test files it is, yeah, the output base is base 10, so we need to add this guard to every single pattern matching we have. Okay, so we need to add all these guards. So that means we probably need to make these functions public. These 2 functions. Let me bring them out here. I'll probably just take them to the top. Cool. So now they are at the top. We can use this, reuse these guards for every function we have. Just need to copy all this. Bam. And for the otherwise, yeah, we don't care about it. It's and we also have to do the same thing here. Say otherwise. And since we don't care about the output base, good now. So if I copy this function and I paste it here and I try the test again, yeah, all the tests pass. So we can probably submit it with first submit, and yep, we should have it submitted. So let's check. If I refresh this guy, yeah, it says processing. I passed, so I would mark this as complete. And cool. Thanks for watching.